Hi, this is Laura McCafferty, and I'm speaking today with Adam Strange, who's a safety analysis engineer at Duke Energy. And Adam, can you tell us what type of engineer you are?
I'm a nuclear engineer in safety analysis.
Okay. And what inspired you to become an engineer?
In high school, math and science kind of fascinated me, and I wanted to work in an area that would help the environment and also potentially reduce our usage of carbon-based fuels.
And how does what you do help the environment?
Basically, nuclear energy is one of the main baseload fuel types that does not emit greenhouse gases and can have a big impact on reducing our coal and gas consumption.
Great. So what type of post-secondary education was required for you to get this position?
I have a bachelor's of science in nuclear engineering. A master's and PhD are not required, but they do help you. They give you a little bit higher starting salaries, and they also can help you maybe get into other areas that might be a little bit more job specific towards your master's. But it is not required, and our company does also help fund if you would like to go back to school for a master's while you work. So there are still options to go back to school if people are interested.
And Duke is very supportive of that.
Yes. I know several people who have done it. I'm thinking about doing it. There's a online master's for nuclear engineering at NC State that seems interesting to me that I might go forward with in the near future.
Terrific. Can you tell us a little bit about what a safety analysis engineer specifically does?
Basically, in safety analysis, we run some complex computer codes that will simulate the power plant during various events. All nuclear power plants have a license with the Nuclear Regulatory Commission that requires these utilities to operate their plant within certain bounds. Some of these bounds are things like power level, your pressure, and temperatures. Basically, parameters that will maintain the safety of the equipment that you're operating. You don't want to exceed, if a pump can only output so much, you don't want to exceed that bound. So we have a license that will keep us within these bounds. And basically during any postulated event, we must ensure that the plant will react in a manner that will prevent us from exceeding these bounds. So to do this, we use various computer codes to simulate the events, and then anytime like the plant wants to make a change to like a valve, like if they want to switch out valves or they want to switch out a pump or manipulate valves in a different way, or the operators would like to operate the plant in a different manner, we get notified and we have to put the changes into our models and simulate it to make sure that we will not exceed these bounds. So that's the basic gist of what a safety analysis engineer does. There are various other jobs that nuclear engineers are qualified to do. Some of these include core design, and basically what that is every time there's like an outage, anytime we reload the core design people have to design a loading pattern that will provide the power levels that we want and allow the plant to operate in the way that it's supposed to. And in those reload patterns, there's fresh fuel, and then there's once burned fuel that has been in the core for one cycle, which is usually 18 to 24 months, depending on the plant. And then there's also twice burned that's been in there 2 times. So they have to arrange the fuel in a manner so that they'll have a level, they won't have any peak power points. It'll just be a nice level power, a nice equal power level across the core, so we can avoid hot spots. And if there's a hot spot, you could start damaging your fuel rods and that kind of stuff. So that's what the core designers do. There's also radiological engineers that do calculations to determine what dose could be experienced if an event happens, what kind of dose the public could be exposed to, and we have to keep the doses within our NRC limits. So they run computer codes, and anytime stuff changes, they have to run these codes and make sure that we won't exceed those doses if an event should happen. There's also people that are in core thermohydraulics, and they're concerned about the fluid flows and temperatures inside the core, like the flow that's going through the core, the fuel assemblies. Sometimes you might get some vibrations in there, and you can get some fretting on the fuel rods. And if by some chance there's a fuel rod that leaks, they have to be able to determine where the leak is, which fuel assembly has the leak, so we can either take that out during the outage or replace it or move it so that it doesn't become a problem. There's also waste management, which after the fuel has been taken out of the core, it gets put in a spent fuel pool or dry cask storage, and those engineers basically have to ensure that the fuel not go critical, like it won't start creating power by being next to a different another fuel assembly. So they just have to maintain a fuel pattern in the pool or in the dry casks that will not produce power.
And these are all jobs that a nuclear engineer would.
Yes. And some of these jobs, like mechanical engineers, can qualify for as well. Like we, in safety analysis and thermohydraulics, we have several mechanical engineers that work in there as well. So it's fairly a lot of the work that we do in those two groups is mechanical based, but there is an added portion that is nuclear, but it's fairly easy for a mechanical engineer to pick up on.
So in essence, what you guys are doing is making sure that the plant is going to run efficiently, smoothly, and safely.
Exactly.
Okay. And what do you like best about your job?
I like that the work is very challenging. It's a great job to get into, and you learn so much. I learned more in my 6 months starting here than I did in college. And there's a huge variety of work in safety analysis, especially because we get called on by the plant to do various things, and there's people that have been in my group for 20, 30 years, and they're still, we're still doing new and exciting work. And I also work with some really great people, and we do a lot of really great work, and there's just a wealth of knowledge that I can take from these people. So that's pretty much what I like most, is just the variety of work. I'm not doing a monotonous job that I would get bored at.
Mm-hmm. And what would you recommend young people today, what should they do if they're considering getting a career in engineering?
I would recommend that they get involved and take challenging math and science courses and physics to determine, which type of engineering most interests them. I mean, if a person is the type of person that likes doing things that challenges their mind, they would love being engineers. It's a really exciting field. There's a ton of opportunities right now, especially in the nuclear industry with the generational gap. So you have lots of opportunities to move around from within a company to different companies. Different types of jobs are available, and they're all trying to hire young talent to replace the people who are getting ready to retire. So, I mean, basically math and science, you just need to focus on those and figure out which areas you're most interested in, and then talk to your college advisors and let them know what your interests are, and they can help guide you towards an engineering major that will fulfill the things you're looking for. And, I mean, a lot of schools have dual majors, like you can get a mechanical and a nuclear engineering degree in 5 years at several schools. Other, stuff like that. You just got to be able to, you want to think outside the box and make yourself as marketable as possible. So the more stuff you can put on your resume, the better.
Terrific. Well, thank you so much for your time and for explaining all this.
No problem. Thank you very much for giving me the opportunity.
You're welcome.